I'm ready to move on to problem 9. Once again, for this problem, I will encourage you, please do not write or copy as you are watching the video. You will benefit more by working after you watch the video to see if you actually understood, rather than writing while you are watching the video. The goal of this proof is to prove that angle PNR, which is up here, is the same as TNS. These two angles are in the triangles on the left and the right, the outside smaller triangles. So as I'm going through this proof, I should be thinking to myself that a general goal would be to prove the two green triangles are congruent using angle side angle or side angle side, something like that. And once I have done so, then I will be able to say that the pieces are the same using CP/CTC. So I need to in some way prove that these two triangles are congruent. That is my goal. And once I have done that, I will be able to show that those two pieces up there are the same by CP/CTC. The first given was that angle 1 and 4 are congruent to each other. I'm not going to use this in this proof. I'm going to find a way to not use it. It's going to be like a scarf that was unnecessary for me to write, because I'm going to find a different way to use it. I'm sorry, to prove the triangles are congruent without having used it. The second given is that PS is congruent to RT. You'll notice that PS goes all the way from here to here, and RT goes all the way across. Many students will get confused and they'll be like, well, should I mark this piece? Like, where do I put the congruent symbol? What I have consistently done is place it underneath the triangle, and I'll say that this side is the same length as this side. So I have those lines extending past that. I will remind you that our goal was to prove that these two green triangles were the same. So unfortunately, the side PS is too long to be a part of this green triangle. The good news is that I can actually subtract or take away the piece that I do not want from both, RS. I would like to emphasize at this time that I can only use the subtraction postulate if I know that the pieces I'm taking away are the same length as one another. So here I knew the whole thing was the same as this whole thing, and it has to be true that this side is the same as this side because they are the same exact side. So if the entire thing were 12, and this piece in the middle was 5, then each of these pieces on the side would have to be 7. So instead of using numbers, I'm going to be able to say that in a proof. I'm going to say if the whole thing PS is the same as this one, RT, which is already there, then I can subtract the one in the middle. I can get rid of the same one, and the pieces that are left should be the same. So I have PS take away RS is the same as RT take away RS. And notice I'm taking away the same amount from the two pieces. Once I have taken away that segment, the only things that are left, PS take away RS, is PR, and RT take away RS is ST, so I can say that PR is the same as ST. And that is much better for us because those two sides are actually part of the green triangle. The next thing that they told us was that NP is congruent to NT. This was a given as well. From here, I'm going to look at the entire triangle, PNT, the biggest one, and I will notice that the triangle PNT has two sides that are the same as each other. Side PN is the same as side NT. If you have a triangle with two sides that are congruent, it is an isosceles triangle. I'm going to say, because I have the two sides that are the same, the triangle PNT is isosceles. This is the definition of isosceles, that you have two sides that are the same as each other. The reason that I wanted to do this is because now that I know that two sides are the same, that this big triangle is isosceles, it must also be true that two angles are the same, and in this case they are angle NPR and angle NTS. Those must also be the same because the large triangle is isosceles. So I proved that the triangle was isosceles because the two sides were the same. And because it was isosceles, I could also add that the angles would be congruent as well. From here, I can now say that the two green triangles I outlined are congruent by side, angle, side. This is triangle PNR. The one on the left is congruent to, and I have to go in the same order. Angle P goes with angle T, so I should put the T first. N goes with N, and R goes with S. So triangle PNR is the same as triangle TNS. Those are the two green triangles. The first side that I had was that PR was the same as ST. That is in step 3 of my proof. The angles that are congruent are here in step 6, NPR and NTS. And the other side, PN and TN, are here in step 4. I have all of those steps in my proof. I have just proven that the triangles are congruent. Now I can say the pieces are the same by CPCTC. So if these green triangles are congruent, which I've just shown in step 7, then it logically follows that angle PNR is the same as angle TNS. The triangles are the same, therefore the pieces have to be the same as well. I am using the angle symbol, so notice I am not talking about triangles anymore. I am now talking about angles, which is different than what I was saying in step 7. These angles are the same because the triangles are the same. If the triangles are the same, then the pieces that go together must be the same as well.